Hello, everyone. Welcome to the 32nd episode of DevKami. Leong.
And I am Tristan
Yeah, as you
and
can see, we don't have swimming here.
Not-Swee-Meng.
It's a bit under the weather, so let's hope he get well soon. So let's proceed to our usual. What is going on
What's
around tech?
going on this week?
Yeah,
This week in tech. I
yep.
think that's already copyrighted by the Twit network. Have you heard of that YouTube podcast? This week in tech.
By I don't know. I don't offend any people by a
Yeah,
bunch of old folks.
yeah. By
Uh,
it's started by Larry Laporte. It's
yeah,
been like since like 2000s, year 2000s.
yeah.
Yeah. So
I used to,
twit.tv.
yeah, I used to, I think I used to subscribe to that.
Yeah. So like the, the screensavers and all of these like technology stuff. Yeah. So Saturday. So the next event would be Saturday, May 4th. This would be the first Open Hackers Day, Code Network and Meetup. This would be on the 4th at the Hacker Collective
Yep.
in PJ.
Yeah, it's a new movement by Ming, a person that we know.
Mm-hmm.
So he's trying to come up with a space where everybody can join in. Of course, it's most of the time it's not free, but for people who can mentor, it will be free from them. It's
Mm-hmm.
like a space where everybody can gather to do something and to do learning by themselves.
Mm. Do you know how is it different from Indie Hackers by Axel?
Indie hackers is basically doing what the kind of project that you want to do.
Mm-hmm.
But what Ming is trying to do is something like a space for you to learn. It's
So
basically
so
for
there's
people.
an over is an there's an overlap, but it's not exactly the
Yeah,
same.
it's for you. Yeah, it's like people who are interested in tech. They want to learn. They want exposure to people with experience and stuff without going to boot camp because some
Mm.
might argue that it doesn't work that well or doesn't fit
Mm-hmm.
everyone. It's,
I see. Okay, so that's interesting. Um, well, I might pass by and then just take a look on Saturday.
yeah,
This is from 10 a.m. to 6 p.m. So it's a whole day event.
yeah,
Huh, interesting.
yeah.
Yeah, the next one would be on
Ru-
Tuesday, the
Ruby Miller.
7th. Yeah, it's Ruby. This time on Fave. Sorry, at Fave, not at Rapid River. So Fave had kindly volunteered to host our Ruby
Yeah.
meetup. So it's going to be at, well, still at Bangsar South.
Is it still
At
at the room with where the air conditioner is at?
I am not sure. They said it's level 2. So I don't know if that's the same room. I think that was level 3, right?
I
I'm not
don't
sure.
remember. Yeah.
But they will be hosting it.
Yeah.
We have so I'm co-organizing it. There will be 3 speakers, and all of them have very interesting topics. So if you're going, then I will see you there. I will
Yeah.
have to update the meetup link because I haven't
I'll
seen it.
probably go there to do the recording and streaming,
Mhm.
and also to basically to show Jimmy because Jimmy wants to do it. So
Jimmy probably won't be there.
oh damn it!
Yeah, I can
Okay,
record you
but
recording the thing.
I'll be I'll be recording and hopefully show anybody who want to pick up the new setup
Yeah,
because I got a new card that works on Linux and
yeah.
Mac.
I think you'll have to show that tonight.
Yeah.
Like
Oh, okay, yeah,
talk about it tonight. Yeah. And the next one will be Wednesday, the next day. There would be a pitch competition, OTEC APAC, Asia Pacific at Glow Damansara. So at work, so it's like the top floor. There will be a pitch competition at 4 p.m. And at 7 p.m. is the Rust meetup.
yeah. I'll be there as well. It's a
Mhm.
busy week.
It's a
Yeah,
VAS.ai.
yeah. Check
And
it out.
have you been to this place, Zenith
No,
Corporate Park?
no, it's pretty. I think it's around Paradigm Mall.
Hmm.
So it's a very familiar place, but I never get into that before.
Yeah, I don't think I've been to this place before.
Yeah.
Let
Oh,
I'm not sure if I'm going because Rust is not in my radar right now, but we'll
it'll
see.
be is the organizers are Jeffrey, Xiang, and
Mm-hmm.
Ivan.
Mm-hmm.
So Ivan is going to talk about parser combinators.
Mm-hmm.
So if you're into functional programming, it's actually a very common concept. So you probably do it.
Mm-hmm.
There.
Functional programming in Rust.
Yeah.
Rust is like
Yeah.
everything now.
Yeah. It's like everything. And Xiang is doing something more practical. He's gonna do a web scraping demo
Mm,
along with Python. So if you're interested to pick up and you understand Python, a little bit of Python, then it's actually a very good way to pick up Rust via like the side by side coding with Python.
mm. But is wasn't Go the preferred language for scraping after Python?
I no personal opinion. I still use Python to do the process
Mm-hmm.
scraping. If I do a
Because of
simple
is it because
uh,
of Beautiful Soup and all those libraries?
yeah, and also dynamic type helps.
Mm-hmm.
If you want to go in there afterwards, we can go in. But
Okay,
yeah.
because I remember the Go routines make it very easy to
uh,
just crawl everything.
if you are having a crawler, if you just crawl, go around, and you know what you need to get to download and stuff efficiently, then Go
Mm.
makes sense. But if you try to put in a bit of processing in between, then is it's
Python would
pretty
be
much
better.
easier to
Yeah.
do it with
So
less code.
why not both?
Yeah,
So you crawl with Go,
yeah,
save it into a buffer, and then you have processing on
yeah,
Python, which is internal.
yeah. If it's
Mm.
if you're crawling at full speed, then Go makes sense. But if you try to crawl with a bit of finesse, like try not to kill their servers and stuff,
Mm-hmm.
since the speed doesn't matter anyway, so Python will do.
Because I remember one of my ex colleagues who joined a startup, they were trying to crawl
Yeah,
pages because they were doing an e-commerce store and wanted to crawl
depends
their
on
competitors. Yeah.
the way you crawl. Then
Mm-hmm.
for me, I'll try to be nice to whatever that provides the data to me. I don't want them to detect me as a bot as well.
Yeah. Mm-hmm.
So so it doesn't matter.
And the next day, Thursday, the 9th of May, would be Women Who Code
Yeah,
Test Automation Talk.
yeah.
Uh, so that would be at work TTDI. So most likely we might have a DevKami podcast just after
We have
Women Who
that
Code.
after because I'll be
Uh,
there to record as well. Or with a busy week for me.
yeah. Then we probably will just hang out somewhere in there and then just do the
Oh
podcast.
yeah, if they permits us, or we we just hang out around like 7-Eleven and do our
Yeah.
podcast there.
Or Next Academy is there as well.
Yeah,
I'm not sure if they're
I don't
open.
think they are open.
Just um okay. So yeah, so that's our week. It's a jam-packed meetup filled week. We have Ruby, we have Rust, pitch competitions, Hackers Day, lots of things. Oh, we had a Golang meetup last Tuesday,
Yeah.
which was a lot larger than the previous Go meetups that I've been to.
Yeah.
Was there anything special?
Nothing much. It's just the thing is that I actually posted that event much earlier because most of the time I did it very last minute because sometimes I've been trying to find other place that are willing to host us
Mm,
or find some interesting topic to talk about. So if nobody comes out, then these days if nobody comes out, I'll just do Golang onboarding as a YouTube uh,
mm-hmm,
video. But the meetup should be something like always us sharing tips and tricks in production and stuff.
mm-hmm.
Yeah, but also locations. Somehow Central KL is better, and also
Most of the time it is like for any
yeah,
meetup, Central
yeah,
KL.
Central
If
KL
you
is
have to go to PJ, um, it would be good if there's food and drinks, I guess.
yeah,
But like DevOps, for example, they never give away food, but
yeah,
it's always packed with
yeah.
people.
There's been discussion about why we've been talking about whether we want to provide food for DevOps. It's just that the first is the logistic is one issue, like the food, the cleanliness and things. So yeah, that can be discussed. So if especially if the place that hosts the venue that hosts are okay with food, then it's normally okay. But we are really afraid. So I mean, from what I heard, is they're really afraid to make the place dirty and something like that. It's a concern.
I see. Okay. Well, yeah. So that's our events. And you mentioned that you had new equipment for
Yeah,
recording.
I have this.
What is that? It's a
Uh,
small box.
it's a. I threw away the box.
Okay.
Sorry.
It's an HDMI recorder.
It's a HDMI recorder from China. I think they were gonna just hit straight off what topic is what we are gonna do. What we've been doing and gonna do is has in and out, so you don't need a splitter.
So that means it's a pass through. Whatever the signal is from the
Through,
source, it just goes
and
through.
it's actually state of the art USB-C.
But which protocol? USB 2 or 3?
I don't
Because
think
you
it
can have
matters.
a USB-C.
USB 3. What it says here is 3, but anything from China, just don't believe them.
Is it USB 3.1 or
3.0?
3.2?
Yeah.
It's complicated, right?
Yeah. And also something I discovered recently is that I got some really flimsy, really lightweight cables, really cheap. Feels very cheap, but the good thing is very light, so I can actually fit them into a bag instead of the normal traveling bag that I use. So
A USB cable.
yeah. So the problem with that is I think they are they're using the newer standard, so it doesn't work well with some of my older capture cards. So
that's a micro or a USB-C?
no, normal. I mean I mean the HDMI cable.
The HDMI.
Yeah. So this is very cheap. This is $50. The build quality is very solid. It's very heavy.
50 US.
Yeah, compared to others like over $100. So far it worked pretty well. I try to stream at 1080 at 60 FPS, and it's because a lot of chip cards they have issues with overheating, and this one doesn't heat up at all. So so far so good. I'm not sure what they use to weight it, but it feels very solid.
There's a rock
But
inside.
yeah, probably just a placebo. So, but it works pretty well so far, and I actually recommend it for several more people. But if I can have the extra money, I'll probably get them the equipment as well.
I thought you had 2 of these.
I have another one of them, which is actually also sponsored by Luxury, where I work. So that's one. The problem with that is it outputs very high quality video recording, but it only works under Windows.
Oh, so that one only works under Windows. That's so strange because usually you'd think that the output is like a standard protocol.
Not really, because this one actually outputs the keyword for people who want to get it is to find a UVC, Universal Video something. I forgot the full name for it. It means that if any of the UVC device will act as a normal USB video device, just like your webcam. So if you use
that's
this,
what I would expect, right?
Yeah, but that one is a different protocol.
Oh.
Yeah. So need to be really careful about the keywords. And you will see normally, because I don't know what really happened with them, but normally they have a bit of quality disadvantages. Yeah, because I don't know. I'm not sure so much about how all this video stuff works.
So why is it important that this supports Linux?
Because I've been carrying 2 laptops to record every single time. So I normally carry I borrowed a laptop from the office, which is a Windows device to do the recording every single time.
Is that the Surface?
Yeah, that's
Surface 2, I think, right?
Yeah.
Yeah. So that used to be your recording device, and streaming.
It's still not finalized yet, but I'll try to use just this and the MacBook that I'm carrying around, so I don't need to carry one. So But the problem with that is it doesn't work well so far. So let's
Mm.
hope that it. That's why I need to attend. Like when I see the irony is when I got all this new stuff to go around and record more.
Yeah, because I have something. I think I've
Yep.
shown you before
Yep.
the box.
Can't.
It's a
Yeah.
box as well.
Yep.
It does on the fly recording, but the thing that I haven't tested is the broadcast.
Yep.
So maybe on the Ruby meetup, I will
Yeah.
bring
You
that
try.
and we
Yeah.
can
Let's try
try
it
out
out. I'll,
dual stream thing.
yeah. I'll probably still bring at least as a backup. I'll still bring the the Surface around. So
Hmm.
at least we have a backup if it doesn't work.
Is it complicated? I think you mentioned like a page, a GitHub page where all of these equipment were listed.
It's not complicated. It's just to make sure everything works well.
Hmm.
And the challenge is that we tend to take all this USB cabling for granted, like all this thing that we HDMI.
Yeah.
Even though they look the same, they don't function the same,
The standards are
and
different, right?
the standards are different, and also the output might be different because like MacBook they output HTCP
Oh,
signals.
okay, interesting.
So if you are trying to HTTP is like the in techie sense it's like TLS for video signaling.
Mm-hmm.
So if you try to intercept it, you just like
Yeah.
what happened in during the man in the middle attack is that your browser, which in this case your capture device or whatever your TV will detect that the signal is tempered. I'm gonna respect the whatever thing that the compliant like anti-piracy compliant
Mhm.
that I won't I'll just discard the signal instead of displaying it.
But
And cause
is that really how it is? So the TV
yeah,
has the decision to show it or not, or is the TV like because you don't have the key to decrypt
no,
it, it just you
it's the
can.
TV respect it.
Okay,
It's
interesting.
something like understood agreement
So
between like
that's
all
why
these.
there will be like this compliance, right? Like
Yep,
HDCP compliant, and then
yep.
you can do stuff. Mm.
This one also does the stripping
Mhm.
according to them, but normally pass through they does the stripping anyway because they are actually doing man in the middle capturing
Yeah.
and re-outputting. But uh,
Oh,
for
but
for some
if it's
countries, this kind of
sorry, if it's passed through, then if you're doing something processing in between, won't that like lag the
no,
output?
it's just a pass through, just a
Yeah.
capture
Okay.
and
Yeah.
let you through.
Yeah. Sorry, you
But
were saying about countries.
certain countries to acquire this kind of device that strip off the HDCP is illegal.
Hmm.
Yeah, because you know this kind of devices basically means that you can go to rent a let's say Blu-ray movie and output it, and I can re-encode it without any
Yeah.
of those
And
DIM.
because it's a
Yeah,
digital output, HDMI is
yeah,
a digital signal,
yeah,
so it's like
yeah,
perfect one-to-one
yeah,
copy.
yeah. I can record like put it this way. I can record. I don't do this, but people can actually let's say they play something on left something on Netflix on TV, and they can just hook it up, and they have a clean. Even though if slightly downgraded, depends on how good the device is, and you'll be they can archive it without DRM
Mhm.
and share it to other people.
Many people, I think the many of the torrents uh that package
Yeah,
Netflix seasons, let's say it's a web rip, is actually like this, right? Or an
yeah, I
HDMI
think
rip,
so. Yeah,
maybe.
web rip, I think.
I think web rip is like you actually download the thing, so there's no playing, but it's a TV. I don't remember all of these
I don't know how this thing work.
scene stuff. Yeah, well,
Yep,
interesting. Yeah,
I think that's yep. What are you working on?
I've been sucked into the world of
Yeah,
microcontrollers and embedded
yeah.
devices.
The thing that you shared the picture that you shared yesterday
Yeah,
looked like a something like a walking monster,
yeah.
tentacle monster.
That's why I captioned it. It's alive, right?
It's
It's
like
alive.
yeah,
Well, it's technically both
yeah,
alive because I ran the Blinky program, which is the hello world of microcontrollers, right? So maybe if you've been to a talk like a few years ago when IoT was a big thing, most of the presentations would be making an LED light up. And it turns out that making that LED light up is actually a big thing. It's like an accomplishment because it's very, very difficult um, to create that code to flash that onto a microcontroller and then control something else. And yeah, it's and that picture was me getting the light to finally blink
Yeah.
after wiring all of these things. Like, so there's a complicated wiring of all of the pins. Make sure, like, so I've been learning electronics along the way as well, like resistors and voltage and Ohm's law, and why you
Oh,
need a
just
resistor,
for this?
LED. Yep. No,
Okay.
well,
Oh,
it just so happened. So it's more of the learning by the way. How do you say it? Like you're learning along the way. Because, like, for example, when you the first thing, one of the very first things that you will be doing when you're taking maker class or an IoT class with an Arduino, for example, is that you will need to get an LED to light up, right?
yep.
And they'll give you the schematic and then you'll assemble that. So most of the time you'll have like an LED, and then you plug it into the 3.3 volt out of the Arduino. Then you plug it into the breadboard, and then you will have to put in a 220 ohm resistor, and then from that resistor go to the ground of the Arduino. And from that point, like, okay, you can assemble it, you upload the code, the LED blinks, but the ideal student will start asking, why is ground called ground? Like, wasn't there like positive, negative? Why do they keep calling it ground? Where's the negative thing, right? Because the batteries have positive, negative, but now you just change the terms. And then why do I have to have a resistor? And then maybe a curious student would start removing the resistor, plug in the LED, and then the LED like blows up, which is like a rite
And
of
the bulb
passage,
blows
like
up.
Swimming said. Like yeah, that LED blowing up is like a rite of passage. Like, okay, I have popped my LED. I'm not a noob at electronics
You
anymore.
pop your LED.
Yeah, I popped my LED. So it's broken. And like, why is there a resistor, and why does it have to be 220 ohms? Can I do a 10 kilo ohm resistor? Can I do a 100 ohm resistor? Can what happens, right? And then that's when you start like realizing that there's all of these equations around this thing, like the Kirchhoff's law, for example, that says the voltages should be. I don't remember the English translation of the Kirchhoff's law, but there's a calculation regarding all of the resistances and the voltages around the circuit, such that 220 is around the range where it's around the safe range for an LED with a forward voltage of 3.3 volts uh, to get the amps that it needs, such that it's not drawing too much current from the source. So there's all of these computations, and along the way it's like, oh, that's interesting. It's interesting how to think about stepping up or stepping down particular voltages, like
That's
why.
something we often take for granted for people who
Mhm,
haven't touched it.
mhm. Like you just have a 12-volt adapter, or like or everything is USB, for example, 5 volts USB, but not everything runs on 5 volts. Like many electronics run on 3.3 volts, for example. And then like there's the differences between um, linear voltage regulators versus uh, switching converters, like step down converters, basically. I think that's like the Mac chargers were like an innovation for some reason, because they were able to do a switching power supply in such a very, very small space that's quite clean. So just a quick explanation of the switching thing. So because you have AC, right? So you have like a wave. Uh, I think 220 volts here in Malaysia, right? 220 50 kilohertz uh, power supply. And then so it's an AC, but all of our devices here actually run on DC.
Yeah.
And so there needs to be some translation into from AC to 20 to like whatever your device needs. Like most of the time it's like 5 volts or like 9 volts or 12 volts for heavy equipment.
Because
And
DC stands for digital, and most of our stuff runs
no,
on logic circuits.
DC is direct
Direct.
current. Yeah, direct current.
Oh, it's like, oh shit. Okay.
AC is alternating.
So yeah, and
Yeah.
all our logic circuits like one and zeros, DC runs on one and zero. So AC
Uh,
doesn't. Yeah.
yes, so it's easier to because ones and zeros. So here's another thing, right? So you have a pull up and a pull down. So when you pull down to ground, that's generally a zero because you know there's no current. And then if you pull up to whatever your what's called the VCC or the reference voltage, then that's your one. And then anything in between, you're not sure, right? But in DC, because it's just either there or not,
Yeah.
then it's easy to say, okay, you're either zero, you're pulled to ground, or you're pulled towards the reference voltage. But with AC, because it's a sine wave, uh, it's alternating.
Yeah.
You don't know.
It,
There's a lot of things in the middle, and then you don't know. Okay, are we there? Are we actually on the reference voltage or not? So it can be a bit complicated.
I'm probably terrible at this, but the only thing that I remember about AC and DC, the saying was that AC will kill you or DC doesn't.
Uh, that's the Tesla versus Edison debate. So do you know the story about this?
Yeah,
Uh,
I'm not sure about the
so
real story. I just had it at hearsay.
so the yeah, well, maybe the
You might want to
hearsay.
fill it in, yeah.
So that Edison wanted the power grid distribution to be DC, right? Because he was like the proponent of DC. He was the one who did the light bulb experiments, etc. Right? And and his light bulbs run on DC, and so he wanted the power grid to be on DC so that he basically gets all of the patents or whatever. Like the he corners the market there.
Yep.
But Tesla comes along and does AC like alternating current with transformer and proves that he can increase the voltage to high levels and transmit that
To a
current
longer range.
to a longer range without significant power loss, which DC couldn't do because DC has a very short range, like maybe a kilometer or so, and then you need to have like more equipment to boost the signal, to boost the current, basically to push it further. But AC doesn't have as much problem as that, and so of course, practically speaking, AC is much cheaper to because you have less equipment to move along because you can pump AC to higher voltages and it can move along, right? And that's where the AC kills you and DC does not because DC you just need like 9 volts to drive your motor, right?
Yeah.
But AC you need like a high voltage so that it can go through the wire
Yeah.
and then it gets stepped down on the thing. And so what Edison was doing was he was killing animals like elephants with with electricity. Like, look at what
Oh,
220
that's a
volts
bit
will
sad.
do to
Okay.
you, and bam, and then electrocute, and then the elephant dies, and then like so. Basically, it's a fear, uncertainty, and doubt.
Okay. So
1800s.
it's a fake news
Well,
at that time.
yeah, it's technically true, but it's fake news in the sense that that's not what's
Yeah.
how it's supposed to do, right? Yes, high voltages will kill you, but it's also way up, like either
Yeah, of
way up
course.
high or like buried underground, such that you will only get killed if there was like malpractice, like the engineer didn't do their job, or you actually went there and touched it, even though with all of the precautions. And so that was how the rivalry was there. Like Edison just couldn't accept that Tesla's AC was accepted as the standard for power distribution, and we still have AC until now. So that's why we
Oh,
still have
and
all of
another thing, another fun thing that I learned from I used to work in a workshop. I don't build stuff, but I program stuff. So I tend to work with a lot of hands-on engineers. And there was this one colleague. She was the electronic engineer.
Mhm.
So that's what she told me how to recognize the color of the power cable,
Mhm.
because she say red associated with the ladies, ladies are the good guys, so they are the positive.
Okay.
And yeah, and you guys are the negative, which are the blacks.
Okay.
And that's how I can remember them forever.
Interesting. Yeah. So yeah, red is usually the voltage. So it's not a standard, like you can use whatever wire, it still works, right? It's just a wire, but it's a de facto standard that you want to follow it because you will remember better that.
And also, so other people can remember,
And
can
other people
recognize
see
it.
your circuit and they, okay, I understand what it's doing. But yeah, red is where the voltage um like runs through. Well, the voltage runs through everything, but it's the positive side, red, and either black or blue would be your ground. So it's just an easy way to like figure out, okay, this is the positive. I connect the positive to the positive. It's not like magnets. You don't connect the positive to the negative, but you connect the positive to the positive to other, so that it becomes a series, becomes a circuit. Of course, if you go to parallel circuits, then it becomes a different thing. And so while I was going through this, so I've been learning along the way. I was talking about AC being a wave, and then this switching power supplies, and I was learning about because when you switch from a wave to a DC, it's not necessarily a straight line, and that was the difference between linear voltage regulators and switching uh, power supplies. Is that linear voltage regulators usually will output clean current. So meaning if you say it's 3.3 volts, it's 3.3 plus minus zero point 0.1, for example. So it's very, very little ripple. But switching power supplies will usually have more ripples because the way it actually changes is that, PWM,
Yeah,
pulse width
that's why
modulation.
I'm gonna ask.
Yeah, so it actually does that. So it's called switching because it's literally switching on and off
Yeah,
the voltage, so that from 220 it goes down to just
yeah.
9 or 3.3.
Because it's DC is supposed to be 0 and 1. It doesn't go in between, so it's
Yeah.
doing something so it appear like going in between. Am I
hmm
correct?
Well, yeah. So what happens is um because um the signal is still there. Like, so you're basically getting all of the ups, and then it becomes like if it's 220 divided by, let's say you're switching 10 times, so 220 divided by 10 is 22, and then you're switching it once every 22, and so it's like you're only getting 1/10 of the voltage for an amount of time that you're switching, and so you're basically practically getting just 22 volts from the 220 that was switching at 10 times for a period amount of time. So it's average. But because it's started from AC, you have all of these ripples because it's still a sine wave. You're just cutting it wherever, right? And that's where capacitors come in, so that because capacitors is like it's like a bucket that you have to fill first,
It's a
and then
buffer.
yeah, it's like a buffer, and then so that the output becomes more
Yeah,
linear, right?
yeah.
And so the
Uh,
higher the higher capacity your capacitor is, the more linear it is, but of course it's also more wasteful because there's no, like, you have to fill it in first before everything goes through. um
and if I remember correctly, that something that probably people to say this to me to avoid me from messing with their own stuff. Like, but this the thing that people scare me about capacitor is that it'll blow up if you did it wrongly.
the capacitor,
Yeah,
well, you can get electrocuted by a capacitor if you
or
because
because of the discharge.
yeah, because of the discharge, it's like a lot of voltage charged up, and if you've noticed, some of the switching power supplies will have an LED, right? And if you plug them in, the LED lights up, and then if you unplug them or turn off the power supply, the LED is still lighting up, and that LED is actually there to dissipate the capacitor charge, because otherwise, if there's no charge to, like, if there's no circuit to complete in the power supply, the next time you plug that in, it might just, oh, okay, then suddenly it completes, and then the whole voltage uh, of that capacitor goes through, or like if you somehow short the wires, then you get electrocuted with a large amount of voltage.
Yeah, good to
And
know.
yeah, and there were like diodes as well, and then there's the full bridge rectifier concept where from AC, depend on with the circuit design, um, it all outputs all of the positive parts because a diode only allows one way. So from positive, from the cathode to the anode, it doesn't allow voltage to go to the other way. And you can design a circuit such that because it's a sine wave, you go positive and then you have negative voltage and a positive negative voltage. All of the positive goes through, and then when it goes comes for the negative half of the wave, then it goes through a different part of the circuit, and then it becomes positive at the end. So you
Yeah,
have like something like a
yeah,
hopping
I would like that in my
current.
life.
Yeah. So it becomes it's almost DC at the end, but it's very ripply because you have like still a wide how do you
You
call
make
this?
everything positive.
Yeah, makeup. Yeah, you should search full bridge rectifier and then electro boom. I think he has a meme about full bridge rectifiers, and it's and he explains a lot about these things. But he has a lot of so his videos on YouTube has a lot of jump scares where he well things blow up basically, like it's not shouting in front of you, but it's basically like he tries to connect the circuit and it blows up because he connected it
Oh,
wrongly.
the dude that tried to shock himself every single time.
Well, he doesn't try to, I or maybe he does, I'm not sure. It looks like it's
Okay.
I guess he prepares for it, but seems to know
Yeah,
what he's doing, so
yeah,
I
but
think he
it's
knows.
yeah. I think I watched some of the video which were really painful to
Yeah,
me.
so but he does have
Yeah,
lots of good content.
yeah.
But yeah, so
I'll
that
check it
the
out.
full bridge rectifiers, and from that sine wave into all everything positive, and everything is awesome basically. And then you you put a capacitor to linearize the whole thing, so you have a clean DC at the end. So all of these things and learning along the way, and in fact, I feel that because I've been during the meetups and during the times that I'm presenting stuff, I was emphasizing on learning the basics, right? Of learning the basics of the language that you're programming in, the framework. Why do they do certain things that they
Yeah,
do? And I feel that I've even gone even more into the basics because now I understand. Like, okay, this is where all the signals come in. Like, it's y- we live in the digital world and software world where everything is um, can be very precise, but in the electronics world, in the real world, it's not actually precise. When you say I this component gets 3.3 volts, you can actually provide it like from 3.6 to 3.2 and it still works because of generally just the tolerances, right? And if you say like, okay, do you know the voltage of a double A battery?
I don't know. I failed. 4 point something.
No, the double A, the energizer.
I
So
have no idea.
people will say like it's 1.5. It's actually nominally to 1.2 because it comes on a particular range, right? The lipo cells are advertised as 3.7, but its actual fully charged capacity is 4.2. And so all of these tolerances like make you start thinking that okay,
Yeah,
this is how electronics work. Um, there's a lot of leeway on things, like
yeah,
maybe it can affect the way I think about software as well.
yeah. I think that's one of the biggest. I think it's a hubris of software developers or system developers is that they sought to think like uh, going to the path of everything is tightly coupled and
Hmm.
hyper optimized, but
Yeah,
there's no tolerance for anything like even
yeah,
everything can fail.
yeah. So I
So
wanted to talk about that. It's
yeah,
good that you mentioned about tightly
yeah,
coupled things uh because I observed for myself, right? When I'm trying out this circuit diagram, whatever, it's already there, but I don't wire it exactly like that. I put a breadboard and then I wire things in there with jumpers, etc. And I think it's the same picture that you saw, right? It's like I
yeah,
see the schematics. I could have just taken like that chip and then just soldered in all of the wires, and then it looks much nicer because everything is tightly um like all there, it doesn't move,
Yeah.
because if you can see, it's like it's moving a bit and everything is like janky. But it's it's different when you're doing hardware. I don't know what is it in the mindset that when you're doing what hardware, because of all of these like unknowns, tolerances, etc., your mindset is that this is likely to change, and so I will buffer myself from that change by making it easy to change in the first place, by making a breadboard or a jumper so that I can just move things around. I don't solder things until I am sure everything else is tested. Whereas when we're doing software, like, okay, I'm just going to
Yeah, push
use
it to the
this
production.
class. Well, not just that, but even in the software design or architecture, I'm just going to use this class directly because it's not going to change anyway. I know what I'm doing right now, and I know
Yeah,
what's going to happen in the
yeah.
future. And then when the future comes, like, oh, actually, the things have changed. Now it's
All
so
the time.
difficult to change all of these dependencies, right? Because
Yeah,
each class is just calling each other directly instead
yeah,
of like putting an
yeah,
abstract interface in the middle so that they can like you can change one part without changing the
yeah,
other. And it's so the the way things are when you think of, so when I was doing the hardware, I knew that I will probably fail at things, and I want to make it easy to change. This mindset I want to carry over as well to software, where even though I kind of know what the solution is,
yeah,
or generally what the client wants, or what I would like to do in a particular piece of software, I want to approach it in such a way that maybe things will change. And so I want, at this point,
mm,
at the point of now, to buffer myself against that change by
yeah,
making things that I make easy to change. And then maybe after like iterations over and over, when I am more familiar with how
more
things are
matured.
working, yeah, then I start like, okay, I get the donut board. It's called a donut board. So you have a small PCB with everything else, with all of the holes in there, and then you have
Right,
like you
okay.
put in, so it's a donut board. um
Oh,
and then
okay.
you start soldering in things in there. It's still not the final PCB, right? It's still like it's a next evolution.
Yeah,
Things are more stable, but things are still easy to change per component. Like you can just unsolder, desolder one of the components, remove it, and then just put it back there. But generally, the layout stays the same. It's not like a breadboard where it's just a prototype. And then when you start mass producing things, that's when you start ordering PCBs. You start burning your own PCBs, and then you have like you invest in automation, all of these things. But if you'd realized in that spectrum, right? So you have a very um, easily changeable prototype, which is not very stable, which is like the breadboard. You have a jumper, things are just hanging in the air, but it's so easy to change, and you can just pack them up and then you just recreate them later. Then you have something in the middle with a donut board where components are mostly intact, but you can still remove all of the components by yourself because they're large. The capacitor is a big capacitor and those things. And then the other end of the spectrum is like everything is fully automated. You have a PCB, you have an SMD, which is a I forgot what SMD is, because there's a through hole soldering and the SMD, surface mounted devices. So like the really really small. So if you open your computer, you'll have like really really small resistors, capacitors. All of these things are have their big counterparts as well. So this is like very very much designed for mass production. And and along the spectrum is like things are easy to change and things are prototype stage, where things are not easy to change but they're like mass production ready, like very stable. You can have like lots of traffic coming in, and there's a lot of parallels in software development as well. And which is why I think that uh, like this new thing that I got sucked into was a good thing, because I feel that I'm not just learning about electronics but also seeing, like getting all of my experience and seeing it in a different perspective a from a hardware perspective. And also it kind of changes the way I
I think
think.
it's sort of like a humbling experience.
Mm-hmm.
So because the way we were abstracted from everything is very easy to develop this kind of competence that we know what we're doing.
Mm-hmm.
And yeah.
Which
And
and I feel that that's hubris on a lot on the part of a lot of software developers, especially the ones uh that have been software developers for a year or two, who finally had some production applications under their belt, and then they finally start thinking, I can conquer the world, like I
yeah,
can do
I think
anything
that's
as a
happened to
software
me before
developer.
as well. I think it
Yeah.
happened to a lot of us. Yeah.
So and I think it's part of the normal journey, right? And of course, looking back, that, oh yeah, okay, I was really naive. It's like it's the person who was climbing the hill, and then, oh, I'm at the top, and then finally reaching the top, and then, oh, there's actually a mountain
Yeah.
behind this thing that I just
Yeah.
wasn't
It's
able
just a
to.
here, just a, like probably a not even a hill, a heap. You climb a heap, then you discover it's not a hill.
Yeah, and it's really true that the more you know, the more you know that you don't know a lot of
Yeah.
things, and and there's a lot of perspectives, a lot of lenses that you can take a look at like take to look at your experiences through these lenses and learn more about them, like, because you've been through there, but you've only been through those experiences in one way, which is the perspective that you came through going that way. But it's like hiking, right? You go one way and you see, okay, that's the scenery, but you never see the scenery going back the other way. It could be different, and it changes the way you look at things. Yeah, very, very humbling, I would say. Yeah. Actually, speaking of humbling, I'm just segueing into that
Humble
because
bundle.
yes, because Swimming mentioned that the
uh,
Python Humble Bundle
yeah.
is out, and I was asking if I should get the Humble Bundle, because I remember when Humble Bundle first came out, because they would say, okay, pay anything you want.
Yeah, it was a really big thing
Yeah.
last time.
And I paid 0.01 US because that was the minimum. And I was
Oh,
always
yeah,
paying
happens to
0.01
most of us. Yeah.
until they said, okay, the minimum is $1. Okay, fine. Probably for the credit card processing fees on PayPal or Mastercard or whatever credit card. But so I used to buy all of them until they had just a lot of humble bundles, and then I just picked and choose which one I should take. So I
Yeah.
was asking Suimeng, should I pick and buy this Python
Yeah.
uh, bundle? And he said it's not really a,
No, the high tier is not so good. The
the 18
the
US, yeah, the
yeah, the
highest one.
what is I'm actually looking at it right now. It's 15 $15.
Mm.
The fifteen
Mhm.
dollars one is not so good because it's very specific, like Flash development. Twister is very outdated nowadays.
But that's the reactor
Yeah,
model for Python,
it's
right?
actually async.
Yeah,
It's
so
a
it's like the
yeah,
JavaScript engine.
yeah.
Well, not engine, the JavaScript
It's actually
concurrency
the engine
model.
for Python.
Yeah, so it's the concurrency model of JavaScript
Yeah,
applied to Python. So basically, you
yeah,
have your callbacks and all of these things.
yeah.
But so what's the new concurrency paradigm for Python?
Standard library. It's
Yeah,
called
so is,
async
is
IO.
it
Yeah,
threading
async awake. Yeah,
or
not trading.
uh,
It's actually asynchronous. Twister is asynchronous as well. I'm
yeah,
a
it is. They're
I'm
all.
a
I think
Twister
they're all.
developer for many years. So
So they're all concurrency
yeah,
paradigm. So
yeah,
that's called the reactor
yeah.
model, right? Because
Um, the
you have a
only
single
reason,
thread, and then everything just reacts from that thread.
yeah, it's a event. What we call event
Yeah,
based.
based.
That's why it's called reactor. The main thing is called reactor.
Hmm.
But I I I wouldn't advise, like, it's a personal opinion, is that I wouldn't advise people to pick up Twisted. Just learn up the async IO, the standard
Hmm.
async IO, just because most people are using Python 3 anyway. If you're beyond like 3.5, the quality of life of those standard async IO is very good, especially 3.7.
Hmm.
So Twisters has its own benefit, but it also, because it's a very considered ancient library, it comes with a lot of burden on its own as well. So it has its own economics of, if you're familiar with the paradigm to do event-based programming, but it's not relevant. The main thing about that book is really outdated.
I see. Also, the book is,
Yeah,
well, the library is also
yeah. I
outdated.
have the physical book of that, so I know how outdated that is.
Because in Ruby we have a similar library. It's called Event Machine. So it's an event based reactor model. It's generally
but
the same as Twisted.
but
Thing.
nowadays you have the standard library with async IO, direct
But
async IO
you know,
directly.
interestingly, a lot of the bot frameworks are using event based models. So you have a main loop
Yeah,
that just goes around and around and then just responds through messages. And which is also interesting because the Arduino model is also event based. Well, not really event based, but it generally tends towards that because
there
it's a
were
microcontroller.
there were actually two major models with Python last time. One is the event based, which is the the twisted or the eventlet people. Another one is actually a hybrid, which they call green threads,
Mm-hmm.
which spawn off to it's actually from something called shit, I forgot what's the name. It was another packaged version of Python that the people are actually developing PyPy now,
Mm-hmm.
but it spawned off as Greenlet and like G event and stuff. The another way of a similar doing green traits, which is similar to Golang Go routine, like not exactly physical traits, but a smaller traits that live onto another trait or event engines. So that was the two main paradigms of doing concurrency in Python.
Mm-hmm.
Because I think Ruby also has the same bottleneck, which is the global interpreter lock, which
Yes, we do have the GIL. Well, the GIL is there to make programming easier because
yes, that's the
concurrency
point
is
of it.
hard.
Yeah, yeah, um, yeah. That's what I always want to like. That was the criticism for a lot of from a lot of beginners to Python, but everyone should understand that because of that, it's very easy to do interfacing with C code because like from the like C performs very differently from Python. So the GC and the stuff, the memory handling and stuff are very different. If you try to do it you try to interface with C plus you try to share the memory amongst different processors on threads, it can get really complicated.
And yeah, and like because it's basically unfettered access to all memory locations, you can
Yep.
just overwrite each other's
Yep.
memory locations, and you have no idea what happened
Yeah.
because it's just it it's undefined behavior what's happening.
Yep.
Yeah, so I'm looking at the YouTube chat. I think we have a few people uh there.
Oh,
Also,
okay.
Nicholas said that after the test automation, it will be the start of the fasting month. And
Yeah.
so we'll see. So this was discussed as well with the Meetup
I
cartel.
think the day I think the day where the test automation meetup is the first day of the fasting.
Mhm. Yeah, so yeah, the Meetup cartel was talking about it. That what I wonder what will happen with the
Hey
uh,
Jimmy, come on, Jimmy, you should join us here.
that
Jimmy,
what would happen to the Meetup attendance during the fasting month. But
yeah,
yeah, we'll
yeah.
see. Yeah, and Jimmy's watching, but he's not either. No,
You're
Jimmy's also
supposed to
not
be
well.
here, man.
Jimmy's also not well. He's not
Okay,
able
okay.
to.
Get well
Uh,
soon. Drink more water.
just came back from Avengers.
Okay.
Okay, so Amirul says he was
Yeah,
zoning out when I was talking about electronics engineering. It could be it's probably I'm probably explaining things really badly because I'm still a noob at these things. But it's something that I feel that there's like a lot of things that I don't know
uh-huh,
that I want to know, and it's a stream of consciousness
yeah.
thing. So um, let's see.
Jimmy, don't kill yourself, please. Drink water, not Listerine.
Yeah. Yeah, so but yeah, so speaking of the electronics engineering and all of these things, the things that I'm working with right now, the ESP01, so if you're going to be googling, it's called the ESP8266, or its elder and more capable successor, the ESP32. They're they're also working with the Arduino IDE. So that means you can, yes, YouTube Electroboom, exactly. Everything I know from Electroboom. Jimmy, I wanted to show Electroboom stuff to Hala and then tell her, hey, look, this is what I've learned so far. But I was afraid that she would
Boom
just kick
herself.
me. No, no, just kick me out, because it's like, why are you learning all of these things? This is not the wrong way of doing the stuff. But anyway, Hala is a colleague of mine that actually graduated with an electronics engineering degree, who is now transitioned into software. And she said that software is much easier because everything is so predictable. That yeah. So if you're interested, if in getting into electronics, so take a look at those two chips. They're Arduino compatible. Well, the Arduino IDE compatible. They have a different chip processor, but things that you can do with the Arduino, you can do it there. But what's so special about it is that it's so much cheaper than Arduino, and also you have Wi-Fi and Bluetooth low energy for the ESP32, and so you are actually able to interface not just with a serial connection or just do the normal Arduino things, like do a motor or like blink lights or like do a motor servo or whatever. You can also control it remotely wirelessly. So you don't need to have like a wire snaking through and then doing your
Yep.
commands. And so that's why it's apparently a lot of the home automation stuff was built, many of them were built on these chips. And some there's even like this niche hacking group where hacker group, not the hacker cracking thing, but like people who just want to
Build stuff. Build stuff.
yeah, build stuff and then find out how things work, where they go off and see like smart switches, for example, like Wi-Fi enabled switches, and find out, oh, it's an ESP8266, and then flash a new firmware
Yeah.
there and make it do something else, like
Yeah.
I don't know, make it
I've
watch your
always
plants or
basically
whatever.
basically thing plus ESP8266 equals smart thing.
Yes, that's a smart device. It becomes a
Yeah.
smart device because now, and it's actually interesting. When it first started out, it started out with an ESP01, which I'm working with right now, 512 kilobytes of flash, and it's like very small, so you have to really just do things, and everyone just thought, oh, it can do Wi-Fi, to output serial through UART, and then talk to an Arduino so that the Arduino can do the processing, right? And for many most of the time, that's how things are. And then people discovered it actually has a microcontroller inside that is as capable as the Arduino. And so your Arduino is now in this tiny 1 centimeter by 2 centimeter package that you can just put somewhere, has Wi-Fi, just power it with 3.3 volts, and it has deep sleep. And it's just okay. Now you can just connect it to a
Yeah.
thermometer and ping Twitter
Yeah.
what the temperature is in your room every minute or something,
Yeah.
right?
I want my morning shower to be at the right temperature.
Yeah. So and it's really interesting, and I would, so for people who are listening, I would really suggest and recommend that you go even further into the basics, where software came from, the actual hardware.
Mm.
Because remember, the programs from before, they were not like typed in, there were actual
Yep.
circuits, the logic circuits. If you were doing all of these things, the logic, like and or
Yeah.
XOR, all of these things, they're
Also,
actually gates. The gates are actually able to be implemented through hardware.
yep. And also, one part of functional programming, like the logic programming and stuff,
Mhm.
actually looks the same as how you program switches and stuff.
Mm. Which is also interesting that because there is a like everything we do in software actually came from the
Yep.
basics of that hardware. That's why you'll have people doing full-blown computers in Minecraft, right? So
Yep.
they build logic switches, gates, etc. on Minecraft that can do actual computation is because everything started from hardware. They're just re-implementing the thing on a virtual world that can simulate these things. So it's a really a different world out there, and it's also interesting if you're coming from a software development world, because like I said, it changes the perspective of how you view things, and maybe it makes you a better software developer in the end. Who knows? Yes, so it's
Yeah,
11.
it's 11. It's really
Time passes
fast.
by so
Yeah,
quickly when
yeah.
you're having fun.
Even without swimming around.
So we will see you
So
again
yep.
next week, Thursday. Thursday will be Women Who Code, so we'll figure out how we do our podcast
Yeah.
that time.
Probably
Maybe
get them to be on the show.
yeah, or maybe we'll do a
Sweet.
walking vlog. Like we just selfie ourselves and then
Yeah.
we're just walking
Yeah. Probably
across
just a
the sky.
special.
We'll see. Yeah.
Yep. I guess that's about it. See you guys
See you
next week.
again next week.
Yep. Bye.
Bye.